Yes, I am based in Florida, so I am used to the heat. However, you have cranked it up temperature-wise a little higher this lab here. But we still win, I think, on humidity. I work for VMware. I'm a lead education engineer there, and both create trainings, help enable other educators at VMware to create quality trainings, and then also do some talks and live deliveries, recorded, self-paced, etc. Before that, I did it at other companies, like Elasticsearch, and then also I used to teach at night as an adjunct professor at my alma mater, which was Rochester Institute of Technology in Rochester, New York. And that was a programmer before I started into education. And one other real fun fact, this January, I will probably be one of the handful of people that is still using one of the oldest smartwatches. I still keep a Pebble alive and running on my wrist. So, okay, all right. So basically, what I'm going to do is let's talk a little bit about containers, why they exist, how they can help you. Then I'm going to do a quick demo so we can get some concrete reinforcement and actually see it in action. Then I'm going to talk about how we use it, containers, sort of the dog fooding thing, to create the educational actual instructions that we have our students go through. And then open it up and do a demo on that, and then some Q&A. So, containers is one piece of a journey called cloud native, and it makes up three things: container package, dynamically managed, and microservice oriented. Another big thing I do, which is Kubernetes, you might have heard of it, is covered by the bottom two. But it's fundamentally based around the first, which is that we have packaged, isolated units of work that we can run. We extrapolate ourselves away from knowing about what's installed on your operating system, what kind of operating system you're using, and all that fun stuff. And so you might say to yourself, well, why? Why would I need to use this? Especially when, hey, Brian, you're from VMware. You got VM in the name of your company, virtual machines, you sort of pioneered the stuff. I can use those. Well, yes, we can, and it's been a great tool, virtual machines, right? Take one physical computer, and instead of having to just have it only run one operating system at a time, it can run multiple at a time. A great thing. However, that great thing does come with a cost. It completely, 100% abstracts away the physical layer. Well, sometimes we don't need all of that, right? Just like when we buy maybe the 4x4 extended cab four-wheel drive truck, but we maybe use it 0.1% of the time. So then we have two cars or we change it. And so that's where the containers come in. And it also allows us so that we can isolate things. If you've ever been in budget or you're limited on hardware, right? You can say, well, I really like maybe 12 virtual machines. And the IT infrastructure folks come to you and say, well, why? That's going to be a lot. You know, why do you need that many? Oh, because I got all these different components and things that are running, and I want them to be completely separate of one another, isolated. And they're like, well, I can see that for those two important ones, but for all that other little stuff, can you just put them on one? And then you sort of like shrug your shoulders and you say, okay, I guess so for the sake of cost saving. Well, with containers, because they are so lightweight, we don't have to worry about that. It allows us to do things much lighter. The second big thing, which doesn't get talked about a lot, is programmatic construction. When you make a virtual machine, you have an option. You can boot it up on your computer, and then you can log into it. Whether it's Windows, you might install software on it, customize it, and then save it, make a snapshot, make an image of it, and say, hey, okay, this is good. I can let other people boot up this virtual machine. The problem is, it was manually done. There are some ways that you can make virtual machines in a scripted, automated, reproducible manner. However, the reality is, because that infrastructure tool doesn't require it, many people don't do it. Hence, what do we do in society for such things? We put in forcing functions. And we do the same thing in technology, right? So a forcing function of containers, and like when you create a Docker image, is you have to write this thing called a build file. And it's the steps and instructions for you to make that isolated unit of work. You can't make it anywhere else. And then this gets checked into source control too, so that it's version control. And it's traceable and we know what's changed. So we always make it by running programmatic scripts and such. So what it boils down to then, from a nomenclature perspective, is that unit of work is called an image, and then when it's actually running, it's called a container. And you'll see this when I do the demo. I run the command docker images. It gives me the actual packages I've had that I've created. And then I have a docker ps, which shows me the running things. This is off of my laptop when I made this, and as you can see, I can have multiple images and I can have multiple running containers, so I could run 4 databases off the same image. That becomes a fundamental difference between a virtual machine and a container. If I start up 10 virtual machines, that's 10 basically individual file systems where state is being saved. If I log on to 2 of them and change a file on the desktop or make a notepad or something like that, that state is saved on the file system that backs those 2 VMs, not on the other 8. With containers, everything is ephemeral, so temporary. And what this helps is it helps us, once again, as a forcing function to make sure we don't manually go in when something's running and tweak it. Instead, we throw it away and we make a new one that has the update on it. That's another fundamental difference. So, finally, when we make stories on things like this, we talked about how we build it, we talked about how we run it. Well, where do we put the goods we produce, right? Do we store it in a warehouse? Do we ship it out to the end customer? In this world, our containers are put inside of a registry. Registry is a place where you can store all of those images that you've built. Okay? There's public ones, like Docker Hub, and then you can have private ones. So many organizations or enterprises have private ones inside where their teams that create software put the images too. I'll be showing you an example of both. So, with no further ado, I want to do a little demo showing a lab I have built that's going to show us about how we build images. And also, then we're going to pay attention because the lab instructions in that were also built with a container and are running with a container, and then I'll show how that's done. Hopefully. And please, remember. Oh, I almost forgot. Okay. So, if you want to follow along, the lab I'm going to use is at this QR code. I don't know if your phones will reach it from there, but it was a fun thing to try. It's also via.vmw.com/E-JYE. This is a site that I have some content on, as well as my colleagues. It's called Kube, K-U-B-E.Academy. There's free training out there in video form, and then online exercises with hosted lab environment. I'll make it bigger. And so once this thing gets going, here we have a remote terminal here. Okay? And then there's lab instructions on the left. And this is the lab that goes along with the lecture I just talked about. So we can look at what's available to us. Nothing has been built. And if we look, nothing is running. So we should go through these lab instructions. And basically, it's a little web front end that we're going to make and use. We're going to author this is a Docker file that says we're going to start with Linux, an Ubuntu image, and we're going to build it. So I'm going to cheat instead of typing that in. I'm going to curl it. Okay. Now we're going to run this Docker build command, which is going to follow the steps to actually do that build. Remember what I said? I said that Docker build file is a way to programmatically create instructions that we would run. Notice it's steps, step 1, 2, 3, 4, 5, 6, 7, which basically corresponds to the line in that build file. This would be the same as if we were running like a Windows machine saying, hey, brand new server, log in, install this, install that, set the background to this, set the password to that, set all the customizations, and then take a picture of it and snap it as a virtual machine. This is doing the same thing, but in a container, in an image. So now if I do Docker images, I see two of them actually. I see the one I just built, which is 38 seconds old. Newborn. I also see the Ubuntu one, and you're like, well, where did that come from? Well, that's because in computer science and technology, very rarely do we start from scratch. We always copy paste from somewhere else or stand on the shoulder of others. Line number 1 here says from Ubuntu, meaning that we're going to take another Docker image that exists out there that represents the Ubuntu operating system, and then we're going to layer on top of it. So we're not starting with a blank sheet of paper. Ironically, if we were to start with a blank sheet of paper, instead of the word Ubuntu there, it would actually be the word scratch, as the slang of we are starting from scratch. We can do the same thing for the database backend, where we can take and start with a MySQL version. There we go. We can do the build of it, and we should see the same thing. It's pulling down the MySQL image that it needs to start with. Then we're going to layer on top of it our stuff. And what we're going to layer on top of our stuff is the schema for the database of the application. If we do a Docker image, we now have 4 of them. The database and the front end. We can then start these things up. And we're doing the running portion. So we're going to start the database, let it initialize for about 20 seconds or so, then start the web server, and then we should be able to actually browse and see the content. Now, while that's going on, see these lab instructions on the left? They're actually were authored by myself and by my team. And we have them running in here. Now, we didn't write raw HTML to make those. That would be tedious. We used tooling to make it. But the tooling requires tools. And it requires your laptop to be set up a certain way and so on and so forth. And so what I'm going to do is show how we use that as well. So we have to finish and make sure this thing works. Almost there. Okay, we've got it running. We should be good. And if we echo this and I click this link. Oh, we need to wait just a little bit. Hopefully, it should be there. If not, I'll come back to it. It has to do health checks to make sure it's healthy. Nothing will come back. Okay. Might not have waited long enough. For the sake of time, I'll move on to the next part, which is the lab instruction. Okay. So that was an example of just seeing how we can build this stuff. Now let's go back and let's talk about those instructions that we saw on the left side of the screen. That left side of the screen, those lab instructions, that's not hand-coded HTML. We use a tool. It's called Sphinx, and then there's also a technical documentation group, and they have a theme called Read the Docs, as in go read the docs, to encourage good technical documentation. And so what we do is, we need to have those tools. But, you know, it starts to get old, right, when people come onto your team, or maybe if you're creating lab exercises for your students and so on and so forth, and you're like, before they can even start to do what you're trying to teach them, they got to make sure that does their laptop or the system that they're working on meet these requirements? Do they have the right version of this installed, the right version of that installed? And it starts to get a little old because you spend most of your time with the stuff that's not the learning objective. So we do the same thing here on our education team so that the people producing the content don't have to have all that tooling set up and configured properly. Instead, all they have to have is the container runtime on their laptop. They check out the code, and they just run the Docker command, and everything happens. They don't need to install that. They don't need to worry about their laptop or personal machine or work machine being changed. And once again, we need two steps. We need a build process where we produce the HTML. Then we have a runtime process where we take that HTML and we put it inside another container that runs a web server that then hosts that left side of the screen we saw. If we were to do a look at the Docker file for the build side of it, it looks like the following. We're basically starting with that Sphinx tooling has a Docker image that they provide. We copy our lab material into there, our source code, which I'll show in a second. Set some settings of like what version do we want stamped on it and so on and so forth, and then run it. Even though it's very old tooling, I like make scripts. Make scripts tend to be pretty standard. Then we have the same thing on the runtime. We produced that previous thing, produced and generated HTML for us for that website. But now we got to put it somewhere. So we start with Nginx, which is a very popular static web server, and we basically copy the result of the previous step that we did into it and package it up as a container so it can be run as well. Let's take a look at that. This is the source code for that lab that we looked at. I know it might not be the largest here, but we'll make it a little bit better. And that lab 1 is written in a markdown format RST and then rendered with that Sphinx. So a lot of the things that you'll see here, start lab 1, prepare your lab, etc. This is what we offered it in, not HTML. But it's friendly for authoring that documentation. So now let's go and make it work. Okay. So this is on my personal machine right here. There are no, there's some Docker images there, but they are for other items. So what I'm going to do is I'm going to run a command that builds these. Okay. And so I'm going to also pass a version to it to prove that we're actually running a demo here. Right? So I'm going to make an HTML site of that using a Docker container. And then I'm also going to make a PDF version of that using a Docker container. And then we'll start up and run the web server. And none of the tooling is actually installed on my laptop. So it's going out, it's building the HTML website, running the Docker container to actually do that build, pulling down the Sphinx one that I talked about earlier, making the PDF one build a lot faster here because I have it some stuff cached. And we should have it. So if I open, we should have a Working Connections 2022 PDF that was just made of the lab instructions. This is a PDF version of the HTML you saw on the KubeAcademy site. And then I can also run a web server. Let me show you here. Sorry, new stuff's everywhere. Always. Okay. So, local host, E. Nothing's running right now. And I will go back to here. And if I look at Docker images produced, it's wrapping a little bit. Sorry about that. There we go. About a minute ago, it made that working connections version of the course. And if I run it, I'm saying, hey, run that course, but with that version. The web server, I don't have Nginx installed on my laptop. I go back to here, and it's now running on my machine, and notice the version is generated, it was injected in at runtime from the command line that I ran. And so this is the same lab instructions that you saw rendered on the left side of the screen of the KubeAcademy site. And so here's another sort of maybe practical use case about how we use containers in our education program, not only for authoring content, but also then hosting it in our lab environments for our courses. And if that kind of stuff interests you, the next step is I ran a bunch of commands manually still to like start the server, say I'm going to do the build. If you're curious, there's a lot of stuff in the Kubernetes world where it takes this, the cloud native principle of container package, and then takes it and says, instead of doing things the imperative way, let's do them the declarative way. And what that means is, instead of, as the operator, telling the system what to do, I'm going to tell the system how I want things to be, and then I'm hands off. And the system is now performing the actions to get me there. And the example I like to use is, it dates myself, but goes back to like one of my earlier cars where I had a climate control system like the following. And guess what? If I was getting too cold or too hot and I didn't reach over there and do something, well, nothing else was going to happen. It was up to me, the operator, to make those instructions and tell the system what to do. And then we modernized, right? And we went to a good climate control system where we tell the car, this is the temperature I'd like, how I'd like the system, the state to be. It's still doing the same things. Lowering the fan, raising the fan, adjusting the flapper, heat, cool, etc. But it's hands off. It's doing what it needs to do to get to the desired state. And that's the next phase, which is the Kubernetes phase. If you're curious, there's content out there on that as well. So with that, that was the end of prepared material. I hope I didn't bore you all too much and you all were able to finish your lunch. But I appreciate that you allow me to talk. And if you have any questions, I'm happy to field them now on this topic, any of the demo stuff I did, or anything else.